Welcome back to Further Solutions Academy. Further Solutions Academy. Kindly share the video among your friends, your classmates, and subscribe if you have not subscribed before. Kindly do so now. At this point, we have a lot of videos for you on our platform. It means you can come here and learn any topic of your choice: mathematics, physics, and chemistry. On this video, I'll be working on integration by partial fraction. That's what I'm going to be working on this video. Normally we have videos that explain integration by partial fraction already, but the video is of like a 1 hour video which is embedded in it. But the problem now is that there are questions that is being sent from one of our students, which we use the opportunity to explain integration by partial fraction. Meanwhile, before you watch this video, kindly watch videos on the partial fraction. You know, we have explained the three cases, which is proper, improper, and mixed fraction, and everything is placed on the form of equation, which is can be linear, all over quadratic. That is what we are talking about. It can also be cubic, all over. It can also be quadratic, all over cubic. Now, anyhow it is, this is a proper fraction. This is called proper fraction. Now, but when the story changed, we are having quadratic. Let me use quadratic all over linear. This is known as improper fraction. Improper fraction. That is what we are talking about. Now, with help of that video on the partial fraction, you will understand those things very well and how to handle it. Now, from improper fraction, you will understand what is called mixed fraction. Now, mixed fraction, it means you are going on a long division or your synthetic method, or any way you want to go, that you will be having your quotient plus remainder all over divisor. Please take note of that. That is what we are talking about on that area. Please try to be on that video for better understanding. Now, but I have some questions here which I need to explain, so that I will make 3 videos on this because of the cases. Now, question number 1, you are asked to do something like this. Integrate 2x plus 1 divided by x plus 1 bracket of x plus 1 squared with respect of x. That is number 1. And I will solve this on this video. This is what I'm going to be working on this video. The remaining 2 videos, the remaining questions are the second one, which is I have integrate 5x squared plus x plus 12 divided by x bracket of x plus 4, and with respect of what? The x. And the third one, it will be integral of 2x cubed minus 2x squared 2x minus 7 divided by x squared x minus 2 with respect of what? The x. Now, these 3 videos, video 1, video 2, video 3, so that you will have it all. Now, let me bracket this. It means try as much as possible to watch video on integration by parts. Now, let's try to solve this and see how it will be. Solution to this one. Now, before now, I've explained type of fraction, improper and proper and mixed fractions. Now, likewise here, when I have something like this, this is known as complex. Sorry, this fraction is known as complex fraction. Please take note of that. This is complex fraction. Now, I will now think away from making my complex fraction to be a simple fraction, because you cannot integrate complex fraction. You cannot integrate complex fraction. Please take note of that. You cannot integrate complex fraction. It's not possible. Now, I have to think of a way of resolving this to what? Partial fraction, by having 2x plus 1 divided by x plus 1 and x plus 1. Is it 1 or 2? It should be 2. Sorry, from the question, it should be 2. Oh, plus 2. Thank you. plus 2, now squared. Now I'm working on the partial fraction now. This implies equivalent to a all over what? X plus 1 plus b all over x plus 1, plus 2 plus c all over x plus 2 squared. That is, it means repeated power. Now, I've explained before now that when I have something like this, s all over s squared plus 1, okay, plus s plus 1 squared. Now, what will I do here? I will have a all over s plus 1 plus b all over s plus 1 squared. Now, the power will be repeated. If it is 3, you move on to the top power of 3. Now, the same thing that happened here, first and the second. Now, by solving the partial fraction, which I don't need to explain myself, with the video on partial fraction, you will understand that. Now, but for those that are joining, I think it means I'll be having 2x plus 1. It will be equals to a s plus 2 squared plus b bracket of s plus 1, s plus 2, and plus c bracket of s plus 1. That is what this will be. Now, since I have this, if I should open the bracket, s plus 1, it will be equals to a bracket of s squared plus 4. This is going to be plus 2, plus 4x. And this also will be b into bracket of, I have x squared, I have plus 2, and this plus, that will be plus 3x. Now, and I will be having c bracket of s plus 1. Now, what am I trying to do? I just open the brackets the way it's being done. Now, at this point, I can now compare the coefficient of this 1 squared. Now, I think I'll be having as squared plus bx squared equals to 0s squared, because 0s squared was not here. Now, which implies a plus b plus equals to what is 0. That's equation 1. Please look at that. Equation 1. And also, I will be having a 4x plus 3bx plus cs equals to 2x. Now, which implies 4a plus 3b plus c equals to 2. Equation 2. Now, and the same thing for the last one, which I'll be having 4a plus 2b plus c equals to 1. Now, which implies 4a plus 2b plus c equals to 1. Equation 3. Now, by solving this, I've derived my simultaneous equation, which is now I can go on any convenient method. Now, like me, I would love to go on integration. My matrix. Which matrix will give me better results without problem? Now, don't forget, I'm looking for A and equals to, B equals to, and C equals to. Now, if I should go on matrix, okay, I want to go on matrix. Let me go on matrix. I have 1 is 0, and I have 4, I have 3, I have 1, I have 4, I have 2, I have 1, and this is the matrix of A, B, C, and equals to 0, 2, 1. Now, in matrix, we have different methods of solving matrix also. I can go by inversion method. I can go by Cramer's rule, which is Cramer determinant method. I can go by transformation method. I can go by Gaussian elimination method. As many as I can, anyone that is convenient for me, I'm good to go. Okay, for the cost of, let me just use, for the beginners, let's use Cramer's rule or determinant method. Using determinant method. Okay, I want to use determinant method now. Now, look at this. I will move on by having determinant of this A to be 1. Please take note of that. I have one bracket of 3, 2, 1, 1. I have minus 1 bracket of 4, 3, 2, 4, 1, 4, 4, 1. And this one will be plus 0 of what? I think 0 will not give me something good. I have 3, I have 1 bracket of 1. I have minus 1. I have 4, which is going to be 0. Which it will be 1. Determinant equals to 1. Now, that is determinant. Now, I will now move on to determinant on A. Determinant on A, at this point, I will use this to represent the column of A. The column of A, we have what? 0, 2, 1, and I have 1, 3, 2, 0, 1, 1. Now, can I find determinant of this thing? Determinant of A will be equals to, I have 0 will not give me something good, which is 0 will be provided, minus, I have 2, 1, 1, 1, and plus 0, which is 0 will not give me anything also, which I'll be having this times it, I'll be having minus 1. Determinant of A will be minus 1. Now, it means my A himself will be equal to determinant of A all over determinant of everything, which is going to be what? Minus 1 all over 1, which is minus 1. It means my A is 1. My A is minus 1. Now, I can move on to my B. My determinant of B, please, I have to manage the board, which I'll be having, determinant on B will be equals to, what is my B? I will be having the column on B, which is this column, will turn towards this, which I'll be having 1, 4, 4, and we'll be having 0, 2, 1, and 0, 1, 1. Now, this will be equals to, the only thing that will come up is 1 here, 1 bracket of 2, 1, 1, 1, which I'll be, everything becomes 0, minus 0, plus 0, which, because 0 is 0, now this will be 2 and 1, which is also equals to 1. It means it will be equals to 1. My B will be equals to determinant of of B all over determinant of all, which is equals to what? 1 all over 1, which is equals to 1. My B is 1. Now, remember my C. My C will be, I want to work on C. My C, determinant on C, will be, the column on C will be turned to this, which I'll be having 1, 1, 4, 3, 4, 2, and 0, 1, 1. And also, I'll be having 1 bracket of 3, 1, 2, 1, minus 1 bracket of 4, 1, 4, 1, plus 0. 0 will be shown here. Now, this will be 3, this will be 2. I have 1 bracket of 3 times 1, which is going to be 1, and minus this will be, and it will be 0. Yes, it will be 0, which is going to be 0. Yes, am I saying the right thing? 4 and 3. Okay, which is going to be 0. I'll be having is 0. Hope I'm not making a mistake. 1, 1. Yes. Okay. Now, it means my, hope I'm not making any mistake. No. Okay. Now, oh. 3 and 1. This is going to be 1. Oh, I made mistake. Sorry, because I was looking at it. This is 2, this is 1. If that is the case, thank you. This is going to be 2, and here will be 4. Here will be 4. Here will be 8. 4 minus, that will be what? I will be having 4 minus 8. That will be minus 4, which is going to be what? Minus 4. Yes, I'll be having minus 4. Since I have minus 4, hope I'm not making any other mistake. This one will be with what is on ground now. Here will be 2. Here will be this will be 2. Here will be 3. Sorry for that mistake. Okay. Hope I'm not making any other mistake. Okay. Here will be 6. Here will be 6. Hope I'm not making any mistake. I have 4. This is going to be 2. 2, 2, 2, 4. Now, which is I'll be having 3, 2, 2, 1. 3 multiply. That will be minus 1. Thank you. Which is going to be plus 1. Answer will be 3. Thank you so much. I think I've done that. Now, my A is minus 1. My B is, my C is this. That needs me to rub determinant, which I don't need it. You need to show it when you are asked to do it in any exam, but it's not necessary. Okay. In advance, it's not necessary. I just use that to opportunity to generate my ABC, which I've done that. Now I will now come back to this particular area. This area. Now, which I will be having what is my A bracket all over x plus 1 plus B all over x plus 2 plus C all over x plus 2 squared. Now, at this point, I can integrate. At this point, I can integrate my rest of x, which implies what is my A minus 1 all over what? X plus 1. Okay. What is my B? I have 1 all over x plus 2. And what is my C? My C is 3 all over x plus 3 all squared. Now, with respect of what? The x. Now, I can, property of integration, which I've explained that you can make this known, which is, I can say that 1 all over x plus 1 dx plus integral of 1 all over x plus 2 dx plus 3 all over x plus 2 squared with respect of x. Now, when I integrate this thing, I'll be having ln of what? X plus, minus is here, sorry. Minus of what? 1. This one will be plus ln of x plus 2. Now, this is going to be very technical part. How do I interpret? You have to go by substitution. Now, by substitution, just say that let u equals to what? X plus du will be equals to the x, and this will be what? 1 all over u squared du. Now, which I can do that by so doing that, I will be having this one will turn to minus, which you will know that it will be minus u minus 1, which is I will be having that. It means I will be having minus will be here, and I will be having okay, all divided by u, which is x plus 2 plus k. That is my final answer. That is my final answer. Okay, can you see how simple integration is? The only thing that make me to go far away because of the what? I'm generating my A, B, C. That is all. Once again, don't forget you are home with Further Solutions Academy. In the next video, I'll be working on this, and the next one also this. Try to share and subscribe. Once again, thanks for watching.